In the following example, we're asked to find a volume of rotation formed after rotating the region formed by these curves, so this in here, around the y-axis. So we're rotating here. We need to know that here we have x equals 0, this is y equals 2, this is x8, y2. Now we need to establish the type of rectangle we want to use. In this example, we could use a dx rectangle, as the dx rectangle moves from left to right. The top is always on y equals 2, the bottom is always on the curve. So a dx rectangle will work fine. Now we decide the equation. Since we're using dx, it's parallel to our axis of rotation. That tells us we have to use the shell method. Using the shell method, we need three things. We need the radius, we need the height, and we need the thickness. The thickness in this case is dx. The height means the height of the rectangle at any point here. So that's going to be the top, which is 2, minus the bottom, which in this case is the function, or x to the 1 over 3. The radius is x. That's the distance from the axis to our rectangle. The volume then is going to be 2 pi times the integral from 0 up to 8 of the radius times the height times the thickness. Simplifying that one, we multiply everything by x, we get 2x minus x to the 4 over 3. And integrating gives us x squared minus x to the 7 over 3 times 3 over 7, evaluated from 0 to 8. Substituting those values in then gives us 128 pi over 7. This question could just as easily have been done by using a dy rectangle. The dy rectangle would have the left always on the y-axis and the right always on the curve. Since the purple rectangle here is perpendicular to the axis of rotation, that would be a disk method now, or washer method. And we need the inside radius, the outside radius. Well, if you go ahead and solve that, r and t, the thickness now is dy, which means each of these needs to be x a function of y. Solving y equals x to the 1 over 3 for x means that x equals y cubed. And that's the outside radius, that's the function. Inside radius, since it's on the axis, is 0. We end up with the volume equal to pi times the integral from 0 to 2 now, since it's y, of y3 squared minus 0 squared dy. And you can go ahead and do that, but if you do, the answer is 128 pi over 7. So the same answer. This is 7.